Hey boys and girls, welcome back to another edition of Crush Lusher Television. Okay, we are going to do 2014 number 4. So number 4 means no calculator. This one was on the AB and BC test. So some people who do well on the AP will take BC next year, and so this is kind of the same kind of thing you got to know. So it has some things from this year, and it's going to have some things from next year. So it's sort of a combo. Let's check it out. So I want you to try this one on your own. This is a related rates problem. So if you want to go back and look at your related rates notes, that's okay. A, B, C, D. Pause the video, knock it out, and time yourself for 15 minutes. See if you can do it for 15 minutes or 25 minutes, because that's what the AP is going to be. Either 25 minutes or 15 minutes, depending on the two free response. All right, cool. Let's do it. So we have train A goes back and forth east to west. So east to west, so it goes left to right. So that would mean positive would be going east, and then negative would be going west, left. Train A's velocity measured in meters per minute. Okay, we got that. VA of t. So A, find the average acceleration, okay, of train A over the interval 2 is less than or equal to t is less than or equal to 8. Okay, so here's my notes right here, 2014 number 4. All right, so I know that position, velocity, acceleration. So it gives me the velocity at certain times, and I need to find the acceleration. So the average acceleration, that would just be the rate of change, aka the slope. So t, it wants it at 2 and 8, and then so I want to know what the velocity of train A is at those times. So at 2, it's 100 meters per minute, and then at 8, it's negative 120 meters per minute. And so this right here is going to go, the change in the velocity is negative 220, and the change in the time is 6. And so the average acceleration over that time is negative 220 over 6 meters per minute squared. That. Or if you want to simplify, negative 220 divided by you can just leave it like that if you want. That's fine. Or you can just continue simplifying, whatever you want. But this is fine. This is an acceptable answer. All right. What is B? All right. Let's look and see what it says. All right. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time with 5 is less than, t is less than 8. Give a reason for your answer. Okay, so we need to write a proof. So this is either going to be IVT or MVT. So this is where it kind of tries to trick you, because this is velocity. So it just talks about the velocity. So since we're already here, we're not looking at rate of change. We're just looking at the straight up points on the graph. And we're looking at the points of the graph. This is actually IVT, because we're just looking at the points of the graph. We're not looking at the rate of change. That's the important thing to distinguish. Okay, so let's look at our chart. So between 5 and 8, will the velocity ever equal 100? Yes, that is, because if you go from 40 meters per minute going to the right, going east, and then you go negative 120 from the left, that means sometime you're going to have to hit negative 100. Sometime you have to hit negative 100. So yes, V of t will equal negative 100 on the interval uh, 5 is less than t is less than 8, because V of 5 equals 40 and V of 8 equals negative 20. And what haven't we mentioned yet? Yeah, we haven't mentioned it's continuous. Does it say it's continuous? Because usually it just says it's continuous or differentiable, but it doesn't say that here. Oh yeah, it does. It's given by a differentiable function V of A of t. So since V of A is differentiable, therefore it's continuous. And also motion is inherently continuous, because you're not traveling in time. You're not going from here to here or here to here. You're not like buzzing around without actually time travel or anything, right? And V of t is differentiable, therefore continuous. by the IVT. So you may have written your proof a little bit different, but that's okay. So it doesn't really matter what order it is. So I said, yes, it's going to be this. I talked about the interval, and I talked about the 2 points it's between, and I said it was continuous. And then I cited the IVT. So those things have to be in place. You got to say the velocity has to equal this. You got to say the interval, and you got to say that between these 2 points that I talked about, looking at the y values, because negative 100 is between those two. You got to say it's continuous, and you got to cite the IVT. All those things will get you the points. It doesn't really matter what order you say it. Okay? C, looking good. C, looking good. All right, at time t equals 2, train A's position is 300 meters east of the station. And the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12. Use a trapezoidal sum with the 3 subintervals indicated by the table to approximate the position of train at time t equals 12. Okay, lots of stuff going on. Oh my goodness. Lots of stuff going on, but we can handle it, no problem. So looking at this. So first thing, we know that we have velocity, right? It talks about the position of the train at t equals 12. So the position of the train, so the position of train A at time 12, something like that you can write, or you can write x, doesn't matter, for your position, equals the 300 that it already is, plus the accumulation at time 12 of v of a dt, like that. So it already starts 300 to the east, plus now it's going to move around between 2 and 12, and it's going to move to the east and the west and east and the west. So this is just the accumulated position after it moves from the east to the west, east to the west, however many times it's going to be. And how do you find this? It wants a trapezoidal sum. So this is going to be 1 point right here. And so we have, now I got to figure this out. So I don't remember how to do trapezoidal sum, so I'm just going to draw a picture, no problem. Draw a picture, that helps. So I have 2, 100. I have 5. I'm just drawing this right here, 40. And then I got 8, negative 120. And then I have 12, t equals 12, it's negative 150 is your velocity. So this is v of t, and this is just time. Okay, so trapezoidal sum, so I need 3 trapezoids. So the first one is going to be, so it's going to be up here, here, there it is. There's the first one, like that. So my answer is going to be 300 plus. So now I'm going to do all of the area under the curve here. So I'm going to do these 3 subintervals using my velocity. So it's going to be, this is going to be the base. So it's 1/2 times the base, which is 3, times the height and the height, right? So that's going to be 100 plus 40. Those are the 2 bases because those are the parallel sides. Plus 1/2 times this is going to be 3, because of 5 and 8, the base is going to be 3. Now the height is going to look weird, but the 2 bases are 40 and negative 120. Bam. Plus, I'm running out of room, we'll go over here, plus the last one, so upside down, so this is between 8 and 12, right? So that's going to be 1/2 times 4 is my height, and then my 2 bases are negative 120 plus negative 150. Bam. So it's the 300 that it already is, and then this constitutes the area under the curve, the accumulated position of the train A at between time 2 and 12. Boom. So this is acceptable right here. I think the answer might be 160 or something when you break it down, but this is acceptable, and I'm going to leave it like that. Okay? And this, I'm going to put the units just in case it wants it. That's meters, because we're doing this is the position. So positions in meters. Okay? Nicely done. Still chugging along. We got part D. Awesome. Part D is a fun one. This is going to bring us back. Related rates. Yeah. A second train. Damn. All right. A second train. Train B. travels north of the origin station. Okay, so this train A is going east and west. It looks like train B is going north and south. Okay. At time t, the velocity of train B is given by v of b equals negative 5t squared. Negative 5t squared plus 60t plus 25. Okay. At time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2. Damn. All right. Let's do it. First thing we need a picture. We need a good picture. So here's the train tracks. Train tracks. Na 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 na. Okay. So train A is 300 meters east of the station. This is the station right here. This is the station. Let's say. And then it says train B is 400 meters north of the station. Okay? At time t equals 2. And that's what we're talking about, time t equals 2. And at time t equals 2, the velocity of train A, I can just get off this little chart right here. Get off the little chart right here, is 100. And so it's going east to west, so it's going 100 meters per minute this way. So 100 meters per minute that way. Now, I need to know what this rate of change is. Ooh, this looks like a right triangle, don't it? Right triangle, right triangle, right triangle. Okay, so let's just break it down here a little bit more. So I have no. So this is X, and this is Y, this is Z, let's call it. So we have 400 meters, and this is 300 meters. And this is going this way at 100 meters per minute. So this is 300, this is 400. That's a 3, 4, 5 right triangle, right? So this distance is going to be 500 meters, 3, 4, 5. Use the Pythagorean theorem. And this is also the rate of change I want. I want dz dt. I want how this distance is changing over time between train A right here. This is train A and train B. Got it. Okay. So let's do our chart. X, Y, Z. So we have X is 400 and Y is 300 meters away and Z is 500 meters away. Cool. So dx dt, dy dt, dz dt. This is the question mark right here. dy dt is 100 meters towards the station. All right, so now this is traveling north, so I got to use this to find my velocity here. Then I just have one unknown, and I'm good to go. So that's going to be -5. So V of B at 2 is -5 times 2 squared plus 60 times 2 plus 25. Sorry, I'm scrunching a little bit, but we got to do it. So let's do it in our head. So we have -5 times 4 plus 60 times 2 plus 25 is 125. So meters per minute, 125 meters per minute. Boom. So this is, okay, so we need this. So what is the actual equation I'm using? So it's the Pythagorean theorem, right? X squared plus Y squared equals Z squared. Remember this? Now I have to derive this, because this is the base of the equation right here. So it's dx, so it's 2x dx dt plus 2y dy dt plus equals 2z dz dt. Bam. All right, now we just plug, and chug. So 2 times 4 honey times, this is going this way. So if this is going this way, let's call this negative here. Because this distance is getting less, right? And this distance is getting more. So I gotta say this is negative and this is positive. Because this distance here is getting less because the train is traveling east there.